Okay, for this question, Chapter 2, Question 12, we can see that there's a tank that's open on one end but sealed on the other, and they want us to find what the air pressure inside the tank is. So we're going to label that first. So we're going to label that, let's go pressure, air in the tank, so PAT. So we need to find PAT. And what they've given us is the specific gravity of the block of wood that's floating in the fluid. They tell us the height of the fluid. They also tell us that the wooden block is 75% submerged by volume. So we have to figure out, well, in order to find out what the air pressure is, we'll need to use our pressure equations. So here we have a reference line in purple. So to calculate the pressure on the left side, we'll be using gamma of the fluid times the height of the fluid, which in this case is 0.7 meters. And this pressure must be equivalent to the pressure that's on the right side. So on the right side you would have PAT plus gamma of the fluid times the height, which in this case is 1.1 meters. It does say that they want us to use gauge pressure, so since it's gauge pressure, we can just ignore atmospheric pressure, even though there is atmospheric pressure on the left. But because we're going to be using gauge pressure, we're just going to ignore that and assume it to be 0. So to start, what we need to do is write our equivalence equation. So we know that on the left side, the pressure is equal to, we have gamma of the fluid times the height of the fluid, which is 0.7 meters, and that is equivalent to pressure of the air in the tank plus gamma of the fluid times 1.10 meters, because it's 0.7 meters plus 0.4 meters. That gives 1.1. Now we want to find gamma F we need gamma F in order to solve this. So what we're going to do is we're going to use the block of wood. So let's start with the free body diagram. Okay, in this free body diagram, there's only two forces that are acting on this block of wood, or at least only two forces that we care about. First, we obviously have the weight, so W of the wood. And then because it's floating in a fluid, we also have the force of buoyancy, FB, of the wood. So because the block isn't moving up or down, we know that the forces balance out. So we can write another equation stating that FB wood equals W wood. Now, because the only piece of information that they gave us about the block of wood was that 75% of it was submerged in the fluid, what we have to do is somehow relate these two numbers to volume. So let's start by breaking down the buoyancy force equation, or variable. So buoyancy force is equivalent to gamma of the fluid that it's submerged in times the submerged volume. So let's call the volume of the wood V wood equals total volume of block. So what we can do is, we know that only 75% of it is submerged. So instead of using a different variable like volume displaced or anything like that, we're just going to use 0.75 of V wood. And now W wood, we can break down weight into mass times gravity. So we have M wood times G. Then we can break that down again because mass is actually equivalent to the density of the material times the volume of the material. So now we have our volume. So we do density of wood times V wood times G. Left side is the same. But then, because we don't have density of the wood, we need to break that down because what we do have is specific gravity. And we know that specific gravity, in order to get the density of the wood, you just multiply specific gravity by the density of water at 4 degrees. So we're going to do density of water times the specific weight, or sorry, specific gravity, which is 0.6, times V wood times G. Then I'm just going to copy these down. Okay. Now, last thing we need to do is rearrange so that we can actually solve for the value that we want. Because gamma f is what we want, we're going to leave gamma f by itself. We're going to isolate it. And then we're going to divide the right side by 0.75 V wood. And because we don't have V wood, we can't actually put the number in. But if you see here, they actually cancel out. So we are left with density of water times specific gravity of the wood times G divided by 0.75. So we don't even have to worry about the volume at all. Okay, and then if we do the math on that, we get actually I'll put in the numbers I'm using for this just so we don't forget. So that's 1000, 0.60, 9.807 over 0.75. Gamma f equals equals 7,845.6 newtons per meter cubed. So now that we have gamma f, we can take back our equation from before, that we our equivalent equation for the left side and right side, and then we can solve for it. Solve for PATA. Copy that, bring that down here. Then just do a little arrow so that we can see where it came from, or where we went with it. Alright, perfect. Okay, now because we want PAT, we're just going to rearrange everything real quick. So we have PAT on the left, and PAT is equal to gamma F 0.7 minus gamma F of 1.10. So PAT equals 7845.6 times 0.7 minus 1.10. That gives us PAT equals minus 3,138.24 pascals. So it is a vacuum on the right side, but that makes sense because there's a higher column of fluid on the right side than the left, so the pressure in the right side must be lower than on the left. Otherwise, that makes sense.